Good morning, and welcome to the 38th Annual Chicago TI International World Fair. This year is unprecedented. In all of the years that we have been doing the fair, we have never actually had to do it only online. Now, we have broadcast the fair for the last number of years on Ustream and on YouTube. But this is the first time that we will have no live presentations. Instead, we have a number of videos that presenters have made for us, and we're going to show you those videos. We welcome everyone to the fair, the Chicago TI International World Fair, and we're hopeful that you will stick around for the entire show, which is somewhat truncated this year. It's not as long as it usually is. It usually begins about 9:30, 10 o'clock in the morning, goes till 4 or 5 o'clock in the afternoon. The fair in years past has begun really on a Friday evening with a get-together and a dinner, and sometimes going then to people's rooms and talking TI all night long. Then the following day, the fair itself takes place at the Evanston Public Library in downtown Evanston, Illinois. And then we go from there to have a banquet. We do awards presentations, and after that, we do the infamous pub crawl. Alas, there'll be no infamous pub crawl this year, at least not here. We also sometimes get together, the survivors do at least, from the pub crawl, get together for breakfast on a Sunday morning. Sadly, none of that can take place this year. What will happen this year is all virtual, all pre-recorded, and so without further ado, let's just get right to our first presenter. Our first presenter this year is going to be Greg Mcgill, who's going to talk about setting up the TI Pi, TP, I believe it's called. By the way, if you have any questions, hopefully our presenters will be watching this as well, and we'll be able to answer those questions in the chat function. There'll also be the comments section down below. You can leave comments. Perhaps they will also be answered or responded to live, but the chat section will be open during the presentation, during each of the presentations. So, again, let's get right to it. Greg, take it away.
So let's talk about the TIPI device. TIPI stands for TI Pi, and it was designed by Matt. Jedi Matt 42 is his handle on Atari Age. He designed this as a project because he could never get a hard drive for his TI. So he built the first TIPI, which is this sidecar device. And as you can see, it has pins and a pin header instead of the usual card edge header. So he also designed this 32K memory card that plugs into the side connector on the TI, and the TIPI plugs right into it. It's always fun getting pins to line up, and becomes a setup on the side of your TI. So this is the original design. You plug in a 5-volt power supply here on the 32K card, and that provides the 5 volts for the TIPI. In this plug here, you plug in a connector that connects to the Raspberry Pi, and that can be a Pi 0, like this one right here, Pi 0W, so you have Wi-Fi, which I just soldered a small connector on the back, and it plugs right in just like this, and you have a sort of standalone unit. And it connects to the internet as well as your TI. It has a USB port on it for connecting up devices like a mouse, that can be used on your TI. I'll go over some of those features in another part of the video here. So this is the original. So this guy here, we sold the 32K card first, and then we built and sold the tippies later, after they were designed and built. The second tippy that was released was the Peripheral Expansion Box version, which has got a lot of empty space, but there's room on here to attach a Pi 3 or 4. It connects right up here on the board here, just screws onto the board, and then here's that cable we talked about to connect up to the Pi 3. Or you could plug in that Pi 0 right in the back, either one. Pi 3, Pi 4, anything slower than that probably won't work very well. The Pi 0 has been tested as well. This board here was made by the Brewing Academy, who is now currently making the boards in the United States. The original boards were made by myself and Matt, mostly Matt. And then some other boards were made by a gentleman in Europe. So this is the expansion box. Obviously you need 32K in your expansion box to run assembly language programs, and the programs that this supports need assembly language support. So then the latest version of the Pi Tippy is the combo 32K and pull it apart here. For combo 32K and Tippy board. This has the standard connectors on it that we're all used to having on our TIs, and it plugs in the same as places your, on the side of your TI, just like a speech synthesizer. In fact, this board was designed to fit inside of a speech synthesizer case. I'll give you a little example. So it fits inside the speech synthesizer case. If I put it in the right way, just like the original board did. So I just happen to have this extra speech synthesizer, so it works out great. And then you can access the Raspberry Pi, if you have a Pi 0 inside, through the front door. And I just happen to have a Pi 0 ready to go. This has the connector at a different angle, so it plugs right in to the board like this. I connect up the 5 volts from the TI through this wire, so you don't even need an external power supply for the Raspberry Pi on this model. And like I said, if you put it inside your case, it just fits in here. I have to go into an angle. Get in there. There we go. Then again, like I said, you can open up the door, and inside the door there's the Raspberry Pi's SD card and access to it from there. So that's the latest version. This is a little bit cost reduced, so it's the cheapest of all three. And you can get all these models on arcadechopper.com. Due to the increase in popularity of SAM's software, which required the Peripheral Expansion Box, I decided to have this sidecar SAMs designed and built, and it's available at Arcade Chopper. This card is functionally identical with the pin header to the 32K that the Tippy plugs into. So I can remove the Tippy from the 32K card, plug it directly into the SAM's card, and use it just the same. The SAM's card has a USB connector instead of the barrel connector that the 32K has. So it takes a different power supply, but I also sell a little adapter that works the same. Otherwise, it's identical. Tippy installation requires an SD card with the image flashed to it. We recommend using Balena Etcher to create your SD card, and you can download the image from the Tippy support site. The image burn takes a little while, so you also need obviously a SD card reader on your computer, or you can grab a USB one from Amazon for a couple bucks. Additionally, I sell the cards pre-flashed. Okay, once you have the SD card ready to go, you can plug it into your Raspberry Pi. And power it up. I'm using a Pi 3 in this example here with a cable that I made. You plug the cable into the Tippy. Plug the Tippy into the TI. Plug the power into the memory card. Once the TI is turned on, you can go into Basic and type in call Tippy. And that will load the Tippy configuration tool. Tippy config allows you to set your Wi-Fi settings. It also allows you to map folders on the Tippy drive to be disk 1, disk 2, disk 3, and disk 4. There is no floppy disk emulation on the Tippy. It is just like a hard drive. However, it does do drive mappings, so that way you can use software that only goes to DSK1 to point to the directory on the hard drive that you want. It's pretty interesting. It works with most stuff, but probably 99% of software works just fine. So I'm going to put in my SSID here. And my passcode, and then save it. Now the Raspberry Pi is going to reboot and get an IP address on the internet. So I can see by the light on the Pi that the drive's active and it's blinking. Now if I hit R for reload, the Tippy will wait until the Pi is ready, and then it will get the latest information from it. There it goes. So now I have an IP address on my network. It's also saying that there's an upgrade. The Tippy software is upgraded every time we find an issue with a compatibility or any bugs or any features are added. It is updated on the internet, and then when your Raspberry Pi connects up to the internet and you run Tippy config, it will check to see if there's updates, and you can update by hitting U for upgrade. And I'm going to do an upgrade right now. Upgrades can take anywhere from a couple of minutes to half an hour, and depending on what speed your internet is, it will vary. There's been a couple of questions about upgrades lately because we did some really major upgrade from version 1 to version 2, which upgraded the operating system of the Raspberry Pi, and it also upgraded to a newer version of Python, which is what the software on the Raspberry Pi runs under. It was a significant upgrade, and it did take a really long time. So we recommend that anyone running a Tippy burn the latest disk image, because then the upgrade will only take a couple minutes. Once the update's complete, then it'll say the version number at the top, and I can give you some demonstrations on operating the tippy. Okay, that took a couple minutes. Now it says upgrade complete at the top of the screen here. And now you are able to see that the Pi version now is 2.8 and there's no more updates. So what I'm going to do now is demonstrate a couple of the built-in features of the tippy on the computer. So we'll hit quit. The computer reboots, and I have a final GROM in here, so I have extended basic, whatever I need. So we're going to go back into basic, and we're going to load in an assembly language program file from basic even without the cartridge. I'm going to take the cartridge out. Start over. Now we're back in TI basic, no cartridge. Call tippy net telnet. So there's a telnet program that comes installed on the tippy drive, which will allow you to telnet from your TI to a server on the internet. It supports 40, 80, or 64 columns, whereas the 40 and 64 are the only two sizes that the stock TI video display processor supports. The 80 columns requires an F18A. So we're just going to log into my my BBS. So I put in the keep.net, port 23, and now we're connecting up to my BBS. So we'll say English ANSI, no ANSI graphics, because this isn't for ANSI graphics. My BBS is supposed to be 80 columns, so this looks like a jumble of text, but you can see I'm logging on. So another cool thing you can do with Telnet, I'm just logging off here, is you can Telnet to the Raspberry Pi, because it is a Linux computer, and you can use your TI to reach it. So if I go 40 columns and say localhost 23, then it connects up to the Raspberry Pi. The password and username are tippy. That logs me into the Linux computer that's running on the Raspberry Pi. Then you can do pretty much anything you can do with the local console on the machine. For instance, you can grab a web page. You could, use a CPM emulator on the Pi. Anything you want. So, but I'm not going to show that right now. Exit. Okay, that's Telnet. You could also load programs from the internet. Again, no cartridge here. Call tippy pi.htp.whtech.com/tippy/dm2k. So I'm going to load Disk Manager 2000 from the FTP whtech.com. So it's going out to the internet and it's grabbing each one of the files, and it just loaded Disk Manager 2000 from the HTTP server. So in Disk Manager 2000, I can go to the Tippy drive and you can see the files that are on my Tippy drive right now, which is just 3 files. Tippy config, and then the net subdirectory, which has Telnet. That's what it comes with. And then you can copy files to your Tippy using anything you want, really. You can use a Windows computer. It has a web server built in, so you can use any browser. And it has a file share that you can pull up and map to a drive on your PC. Or you can just use it just like a regular TI and copy files to it from whatever you want. One of the other cool features about Tippy is that it will utilize the devices plugged into the Raspberry Pi as can allow you to access them from the TI. Currently, the only ones that work so far are a mouse, and there's a printer emulation on the Pi that emulates a printer. So I'll demonstrate a couple of those. So what I'm going to do is go into the web browser. This is Stuart's web browser for the TI. Oh, I got to copy some files, so I'm going to redo that. So going to go to my test page on thekeith.net/TI tests. As you can see, I'm using the PC mouse to move the pointer. Let's see, go to this page here. Which has a list of all the other web pages. We can go to Jones here. Pardon the tech talk. He's got a little page with some links and other information about his web pages. The most advanced web page for the TI on the browser is Corey's page, which is myti99.com. It was fun trying to figure out exactly where to click. Oh, I went to the wrong page, but this will work too. This kind of gives you a little example of the graphics that can be done on the web. Click on his nose. The mouse is a little too sensitive. I need to get rid of the mouse. Just a little example of what you can do. Go to myti99.com, which is Corey's webpage. And he has a lot of interesting things on here. You can play his chess game through the web. You can do webmail. You can play Scorched Earth, which is a canon game. You can go to a group chat, which is a web-based chat. You can see people are posting what they've been playing with their TI recently, and I can post a message saying whatever I want. Post, and then next time someone looks at this page, my message will be there. And I can scroll back by using Q. You can scroll up into the messages. So kind of an example of what the Tippy can do. We can also load a few other programs that he made. Called Tippy again. http://myti99.com/chatty is what I call it. It's chat TI. This is basically a instant messenger for the Raspberry Pi. You have to create an account on his server with the browser. So you have to start with the browser. Ports 9918. That's my password. Yep, I guess right. So Chatty allows you to chat with other members of the Tippy community. You can see I hit R for recent chats. You can see the people I've talked to recently. vary here. And of course, when it loads, I can send him a message saying it's your turn, just. And when he logs on, he'll see it. And just hit back to get back. There's also an online game called Snake, which is a version of Snake. Which is on myT99.com. It pulls the high scores from the internet. So whoever gets the highest score gets on the list. Looks like they've run me off the list here. You can play the game. It's basically Snake. Try to get the highest score, etc., etc.
Okay, so to access the web interface, you just go to tippy:9900. And as you can see, this is my main Tippy drive, so it has lots of stuff on it. It was not the example drive I was showing you earlier. You can see all the folders here at the top, and then the files underneath. If a file has a question mark, that means it's not a TI files format file. It is probably a file for either a PC format file or it's a V99 file. If it's a V99 file, you can click on it with the checkbox, go back to the top, and select Convert to TI Files, and it will convert it to TI files for you. That looked like that one was. So if it's not a TI file, V99 file, it won't convert it. But most files you download from the internet are either TI files or V99, or they're a disk image. If it's a disk image, you can say, hey, I want to copy a disk image to this hard drive. So let's see here. We'll go upload a file, choose a file. We'll get a disk image. I'm sure I have one handy here. Let's see. Here we go. There's livingtomb.disk. And that will upload it to the Tippy drive. And that will automatically copy that file to the drive, and I happen to know that this file disk name is Warzone 2 because I had just unpacked this recently. So here's, if I go into the Warzone 2 folder, here's Living Tomb. That was the disk name of the disk. It creates a folder based on the disk name, and that was the disk name. So that's now on my Tippy drive, all unpacked and ready to go. It's very convenient. Now you're looking at a file share that I have set up on my computer. You can see here that the T drive is going to //Tippy. This is a Windows computer. If you go to drive mappings, you go map network drive. You can see it's T, and I just went Tippy. That's really it. That connects it up to this, to the Tippy drive, and then I can access these files directly on my PC. The other interesting thing is that Classic 99 can also access these files directly and read and write to them. So if you're running emulation on your PC, you can basically access the same exact files that are on your TI without having to copy anything anywhere. You just map one of your disk drives to your whatever drive you have mapped on the Tippy on, and then you're fine. So I can go in here and I can add files, delete files, change files. I can access the files using TI-dir tool, whatever I want. You see I have a lot of files in my directories, and what I've done is try to organize things is like under games, I have different titles here. I have extended basic and basic games separated. I have editor assembler 3 and 5 versions, and then all the files are in here. So I can load them up whenever I want. Another nice feature is you can edit and view this basic file source on here by clicking the blue icon, and then I can go in here, make changes to this file, whatever I want. It's just a standard editor, and then it will save it to the drive, and that'll load in basic just fine. So it's kind of nice for debugging and editing your basic programs. This is a program I got off the internet, and you could just do that. It's kind of a nice feature. Okay, so I'm running Classic 99. I have my disk 9 pointing to the T drive on my PC, and then also to the games EA5 directory. So if I go to disk 9 on Classic 99, and it takes a second because there's a lot of files in that directory. There we go. And now I'm looking at my games folder on the Raspberry Pi's drive, the Tippy drive. And it's the same folder as the TI, so I just ran Pitfall from there. So, you know, if you're doing development, you could easily compile on the Classic 99 and then run it on your real console directly from Tippy in a matter of seconds.
Our next presenter is going to be Eric Firestone, who's going to bring us up to date on all of the happenings at CAD Electronics. There are quite a few new developments, and so let's get right to it. Eric?
This is Eric Firestone with CAD Electronics. I'll be demoing some new features of our PC99W emulator. So the first thing we want to do is bring up the PC99W config, and we'll go to Module, Widget, and currently this widget is the Navarone module, and it allows you to have 3 modules that you can individually select. So in slot 1 currently is Bigfoot, and we'll put Buck Rogers in that slot. Actually, it was number 3 that I had selected. 1, we'll put Buck Rogers. We'll put Donkey Kong in 2. And Extended Basic in 3. Change CAD.ini. Close, launch PC99W. If I go to View and Widget, there's the Navarone widget. And currently the 3rd module is selected, so that should be Extended Basic. And it runs. Select the middle module, which is Donkey Kong, do a reset of the emulator. There's Donkey Kong. And Buck Rogers should be in slot number 1. And that's about it for the Navarone widget. And another new feature that we've added, we go to Peripherals, PEB slots. We have the Foundation 128 card, and that's fully emulated. You can select that in the Peripheral Expansion Box. And that concludes the new features. There are a few bug fixes in PC99W. One was the turtle and TI logo wasn't displaying correctly, and that turned out to be a status flag in the subtract function. That has been fixed, and that actually didn't exist in the original PC99 for DOS. And thank you very much. Column text, a mouse, 192K of video RAM, VGA output, full buffering of all the signals, hardware acceleration, and font blitting, which is a CAD exclusive, which was not originally on the 9938. In graphics mode 4, this is a screen that you can actually do using high-speed line drawing and rectangle drawing. Graphics mode 7, kind of the same thing with bitmaps and other line drawing as well. And in this case, you get 256 colors. 80 column text mode. And the availability, boards are on order and parts are in. And hopefully soon I'll have them on the website. And that is about it. Thank you very much. So now we'll move on to the next thing, which is a board we've been working on. This board we're calling the V9938 Hybrid, and the reason we call it hybrid is because it emulates all of the 9918 plus the extended modes of the 9938. This is the microcontroller that's doing all the video processing. This is a CPLD that's used for address decoding. There's actually 4 addresses that are being decoded. That's a programming header for the CPLD. This is the programming header for the microcontroller, crystal oscillator. It's got full buffering of all of the data, address, and control signals, as well as level translation for the STM32F746. This is a 5-volt regulator and a 3.3-volt regulator. These resistors are the video DAC. This component here is a buffer for the 5 volts to the USB for the external mouse. The external mouse can be used in TI-99 programs. And it's got VGA output. On the back of the board is an SD-RAM chip that's used for all the video memory. And there's a reset button on the chip, or on the board. And that's pretty much it for the V9938, and that'll go with the PowerPoint presentation. Thank you very much. There was some concern about the responsiveness of the emulator for the joysticks. And I don't think it was actually mentioned that it's actually a setting for the interrupt speed and for the processor speed. But anyway, those have both been modified, and I'd like to do a little demonstration on that. So that's the end of the CAD demonstration. Thank you.
Now it's time for Rich Gilbertson to talk to us about RXB and compare it with normal XB, I believe. So, once again, let's not waste any time and get right to it.
Okay, this is for the Chicago Fair. Third try. I had problems. Anyways, let's start off with something that interesting. This is going to be Extended Basic. This is RXB. All right, so first thing I want to do is I want to show you something. There's a program called Cantina. So we have old. And Cantina is nothing more than it's 4. There we go. It's just a extended basic program that plays Cantina song from Star Wars. And then RXB, what I did was I said, okay, how come it takes 2 files to do what I can do in 1 file? So I tried to figure out a way to make it do 1 file. Well, the thing is the lack of memory on the TI. So to fix that, I have a command called call PRAM. You'll see RXB has videos of PRAM, a few, like 3 now. What PRAM does is it modifies the lowest and the highest address in the 24K. So you can tell Extended Basic you want more memory or less memory. If you want Extended Basic to only have, let's say, 4K memory, you can do that. And there's demos on that. I did videos. Anyway, so if we go -1, that says that I want the memory to be at FFFF. And then in -24576, this would tell Extended Basic that I want the memory to be at A000. So if we go size, now this is RXB's size for 2020, so it tells you quite a bit more. But anyways, it says the memory for the stack is right there. But look at this. See the memory for the program bytes? That's not normal, is it? That's quite a bit more. That's because we're using from FFF. Normally it would be at, what is it, FFE7, which would normally would be. And then it's normally at A040, so I've added 40 hexadecimal bytes. Well, it's more than 40 because it's 16-bit. So anyway, so it's A00 instead of A040. So I've had quite a little bit of memory. So if we go old, disk 1, and the program is Cantina, well, RXB, Cantina. Whoops, old disk 1. Okay, it's loaded. So if we run both of these and put a timer on them, if you run them both at the same time, RXB beats it by about 15 seconds. But as you can see, RXB loaded the screen instantly because it's all one program versus this. So I was just going to do a demo of that, but I don't think I want to wait for the song to start. It takes forever. So let's reset memory here. Make sure it's reset. Yep, it's back to normal. So anyways, we'll do the same thing here. Okay, so now that we've done that, let's go to the next step. Let's try call files. So in regular Extended Basic, we have call files, and let's say 0. Whoa, nothing changed. Everything's exactly the way it normally is. If we do call files here in RXB, I've rewritten a version of RX. Whoops. Why did I do that? Oh, call files. As you can see, what I've done is you've got more stack. I had to write a new routine for 0 because 0 is not allowed in the disk controllers or anybody else. So I had to override the whole thing. So now you have a call file 0. It gives you more VDP memory. So if you need a few more bytes of VDP memory in a program and you don't have access to disk, now you can do that. Here's another one. Let's go call files in XB. Let's do 15. It can't do that. It can't do more than a certain number. I think it's 13 as high as you can go. Now in RxB, if you want to extract, you want to have up to 15 files. There you go. There's not a lot of memory left. I mean, you only have 5,624 bytes of stack free and program space available now. And it shows you the memory address change. It's at 1F, 8F is the first free address. It goes from 0958 up to that. So yeah, you've lost quite a bit of memory. Anyways, that's one of the things you can do in RxB. So anyways, nothing changed here for Extended Basic. I mean, it didn't do either one of them, so it just crashed. So we've done that. Let's go to the next one. Let's go to joystick. Or yeah, well, let's do this. First off, see, if you run a program and you want so many files open, you have to do this. You have to call files. Yep, well, let's say 3 is normal, but we'll just say call files. And then you have to do a new. Then you can run the program, like disk, file, program, whatever the program is. Well, that's what you normally have to do in Extended Basic. In RxB, you can just do this. Call XB, and then you can put in the name of the program you want to run. Like, let's say this program here, like coincidence. Let's say disk 1, CONC. And we're going to tell it we want to open 3 files. Now you can do 3 files, 1 file, 4 files. It doesn't really matter. It doesn't care. Well, I've already showed that. But what this does is this does for you the call files first, 3. Then it does a new for you automatically. Then it runs the program. There it goes. Oops, 4. Okay, so here's the program. Let's do the same thing in XB. The first part is Extended Basic. Now, the idea is to run this program for 1 hour and then compare the X and just print out the X if you do it. Or if you run it for 7 hours, well, I don't care. Just run it for a while it counts up the X plus 1. And this will tell you how many times the routine's executed. Now, in normal Extended Basic, you get a call coincidence all, then you have a call coincidence, then a call coincidence, call coincidence. Now, notice that each one's on a line number. This means that when you run the program, you have to go back to the subprogram search, find call coincidence, and start over again each time it does this. That's the subprogram search. In RxB, what it does is a call coincidence. It just looks at a comma, and it goes to the next command. It doesn't have to go back to the interpreter, look for another line number, look for the name of the command, and then run that command. So you're going to get better numbers at X. In other words, the number of coincidences you're going to get are going to be a lot more than you would get from Extended Basic. So if you run the program, this one you run from 200. And here you go. Now, you're also going to get something else here you're going to see. If you watch this long enough, you won't see Extended Basic do all 4 minus 1s when it makes a coincidence all 4 times. You're going to see the number of 4 of them at a time over here on RxB a lot more often. And the reason why is because it's doing quicker checks on coincidence. Just run this for a while, then check to see if they're the same. That's proof enough. So we've done that. Let's try another one. For distance, hold disk 1. And we'll go over here and do this. This will improve your Extended Basic programs because they're compatible. They're the same program names. They're the same, XB. Also, RxB runs TI Basic, which you can't do in XB. Well, you can, but not very many programs. RxB runs, I've only found 2 programs that won't work in RxB. One of them uses something illegal that shouldn't even be used in the first place. It's just a quirk of a TI Basic. And then the other one was basically the same kind of problem. And then a third problem we had, I fixed. You can't do it anymore. It won't work. In Extended Basic, it'll just crash. In RxB, it'll say error, that you committed an error. You can't do that. Anyways, let's go back. We'll just do this. We're going to run this one. It's going to do the distance, and then we're going to run, I think it's 220. Oh, what is it? What did I do wrong? Oh, it can't run it. I have to do this. Call 200, run 200. There we go. So anyways, it's the same kind of thing. Run it for an hour and look at the distance difference. And we're going right back to the same problem we had before, which was that Extended Basic on a distance, if you look at it, you see the distance, it has to run the line number each time. That means it has to go find distance in the list of subprograms and then run it. This takes time to do. There's no way you can just jump to a new line number. First you have to search for the next line number, then you have to go load and find that distance name, then you have to run the program. RxB just, a comma. It's in the same routine. It's in the distance program right there. It never left. GPL just jumps to the next thing, which is a comma. It looks for either a bracket or a comma, and it goes to the next command. So it's going to run faster. There's no way around that. That's why that X increases each time. Faster in RxB. And proof of that is, how long we run? Just a minute or so? Print X. 496. Print X. 427. Now, I started this a long time before RxB, and it almost caught it. I mean, like, this was running quite a while before I started over here, and it almost caught it. That's a big difference. So yeah, it's collecting a lot better data. Run for an hour, it's huge. I mean, it's like, I think there's like 800 difference or something like that after a couple hours. Anyways, let's go to the next demo. I have, what's here? We have the next thing. I guess we're going to go with magnify. So, disk 1, magnify. There's the program. Okay, what it's doing here is it's throwing up sprites. This won't run Extended Basic because Extended Basic doesn't have a comma that you can put in here and change magnification factors back and forth. So it's just going to call magnify 1, 2, 1, which is magnification 1, 2, then 1, and it just goes back to 150 and starts over again. Extended Basic, of course, will crash because you can't do that. As you can see, you're looking here, you see both magnified and unmagnified sprites on the same screen at the same time. I thought this would be a cute addition you could do to AXB programs. You don't have to do it quite this fast. You can only do it once in a while to make something indicate something. It'll make it big, then jump it back down again. You can do it a single sprite, or you can do it, a whole bunch of sprites, take your pick. But it is a factor you could use. Normally people have done this by just saying call magnify, then go back and call magnify again. I've seen loops like that, so I just built it into RxB. I thought it'd be a good idea. By the way, it was already in RxB 2015. I just forgot to include documentation on it. Let's go new here, new here. All right, next on the agenda would be, we did coincidence, we did distance, files. Okay, let's do joy motion. Now, old disk 1, this is going to be for XB balloons. And old disk 1, and it's RxB balloons. Oh, it's just balloons. And this. Okay, so what's the difference between these two programs here? I guess what we'll do is we'll just go look at them this way. So first off, we have, in regular Extended Basic, we have like call joystick, TT equals 1, display at, coincidence all, C, and then it does this, you know. And then it does a call motion down here, so we're call coincidence. That's extended basic. And over here in RxB, what we have is a thing called, where'd it go, there it is. Over here, what we have is called joy motion. And what it does is, this is pretty cool. What it does is it does joystick 1, and then you have your X and Y like you normally would. Then it also has number 1 sprite. That's the sprite we're going to be using in joy motion. And then we have a pixel number. Like in motion you would do this. So anyways, that's the number of pixels it moves. So it's similar to the extended basic, but what I've got here is basically call joystick, call key, because it also does the fire detect key also. Not only joystick, but also fire. And then it goes, if there's a button pressed, then now go to at the end can be included on joy motion. I don't have that here. And then it also does an if then else for that go to. So it also does a call motion. So it does all that in one command. What's the difference? Well, let's take a look. This is regular extended basic. Put my gamepad over here. Hit enter. And let's move it around a bit. Okay, here we go. There's a right there. Come on, come on. There we go. Catch it, catch it, catch it. Can you get it? Yep. And where'd it go? There it goes. Can't catch it. As you can tell, the joystick is a little slower because it. One of the problems is, one of the big problems with extended basic is it has multiple commands, and I've built everything into one command. So if we go over here and run it, let's see how fast this is. Well, as you can see, the response time is much quicker. So joy motion in RxB, what you do is just find your extended basic programs with motion inside them along with joystick, and you can speed it up considerably. As you can see, it does work. Stop this program, stop this program. Let's try a different one. I got another one here. How about, I got RxB Lemon and, you know, I only got RxB Lemon. I don't have the other one. So this is RxB Lemon, where you can use the joystick and you can wait for it to put the screen up on screen. It's going to take a second. It is extended basic. Anyways, so I think it's trying to, you know, I should initialize something. I don't know why it's working. 550, what's it doing? It's doing a call peak for something. I don't know why it's working, and I really don't care at the moment. It wasn't that important. I didn't test it. I just ran it a year ago, so my own fault. I think that's pretty much it, other than the one thing what I've been doing lately is, what I've been doing is, I'm trying to make it so what you can do is you can run a program. So the idea is I want to be able to go do this. If you have a program, let's say you have an extended basic program, and using SAMs, what I want you to be able to do is load a bunch of a program, each one with a line number, right? And the idea is that if you do a call SAMS, you could swap out that portion of memory from that line number down and use the same line numbers in the program to add more lines to your extended basic program. So it'd be a little bit like using a subroutine where you go call sub. But the idea was to use the same line numbers. As long as you don't add new variables to it, you could have a 1 meg extended basic program. It just keeps adding more lines in every time you swap out that 4K in SAMS. I do have the SAMS demo. What did I call that thing? I think it's on disk 1. Old disk 1 SAMS demo. Is that what it is? Yeah, SAMS demo. All it's going to do is it's going to go to disk 5. It's going to load. Now what this pload does is, okay, that's the address to load. Like the addresses are going to be like at 2000, 3000, A, B, on. C, D, E, B, E, F. Now these are boundaries in a hexadecimal for where you load your memory. So it's going to be 23 A, B, C, D, E, F, where you want to load that 4K page in SAMS. So I've changed it to a 4K page. It used to be 8K. And it's going to be doing that. It loads those pages into the SAMS memory at these pages. So it's call SAMS that 2000. That's the page number you're going to put in there. It's using P. And then what's going to do is going to cycle through all of them. I've run this demo many times, but we'll run it one more time. All it's doing right now is it's loading off of disk. If you go to disk, what is it, disk 4? No, disk 5? Yeah, there it is. It's loading the pages right there, one at a time. And it's loading them into the SAMS. First it puts them into the SAMS, then it puts them on the screen by using that move command that I showed you. It's in the command here. If we look at the SAMS demo, you can see here what it's doing is it's loading it. Then it moves from RAM, which is at lower 8K, into video, 2079 bytes, from lower 8K 8192 to video screen. Now, this is cycling through on SAMS. This is all in memory. It's cycling through each one of these screens. Now, by the way, it's 4K at a time it's swapping out. Do you think that's fast enough? SAMS is pretty quick. It's not any faster than regular memory, but it is swapping out 4K at a time. It only takes like a few clock cycles to do it. So it's pretty quick. I think it's pretty useful. But I want to be able to do this with extended basic programs where you can make a line number. The trouble is that line number has to be exactly on the boundary, otherwise you're going to have a problem. I suppose you could be outside the boundary, but it's going to mess up the program if it goes to for the line number that doesn't fit. Anyways, this is a short demo I want to do with RxB to show you what 2020 is coming out and to demo the things that I can do. There's a lot of other features I haven't even touched on that I've added to RxB since then. There are videos out there you guys can watch. So have fun at the fair, and we will talk to you guys later. Bye.
Our last presentation of the day is going to be by Barry Miller. Barry is going to talk about using the TP and after hours BBS. Barry, you've got the floor.
Hello, this is Barry Miller. I'm going to talk to you today about some bulletin board software that I worked on over this past summer that may be of interest for TIPI users. The program was originally released by Ed Sham back in 1986 as the After Hours Bulletin Board software. It was written in pure assembly code, editor assembler option number 5, and would run from floppy disk, and it was set up to have a message base and file down and upload areas. With Matt's release of the TIPI, I took on a task of converting that RS-232 based serial code that was in there and converting it over into the TCP protocol so that we could access a bulletin board from the internet on this. I have released the source code in its entirety for the Tippy. It runs on either a Geneve 9640 with a Tippy or a TI 994A with a fully expanded 32K. It does need an editor assembler cartridge with the EA, or excuse me, not the EA, but the 8K RAM on it, because it does need extra memory to run. The mini memory is not suitable for it, but it does need the 8K RAM. Unfortunately, the Final GROM does not support the full 8K of extra memory, so the Final GROM is not an option there to get that extra memory. The program has in its distribution is a 63 megabyte zip file. Basically, you can unzip that file to the Tippy from a Windows computer, and basically you can just then go in and sign in right off the bat and run. When you do that, you've got a bulletin board system that's already pre-configured with 3,312 files, 73 different file categories. I believe it is probably the most robust bulletin boards program out there that will run on a TI 9948 right now. No other program can beat that, as far as at least that I'm aware of. It does support fully upload and downloading. It has 5 message bases, one for the TI 994A, one for the Geneve 9640, programming, buy and sell, and I believe there's another topic that doesn't come off the top of my head. I'm going to go ahead, I'm running this from my Geneve right now, so I'm going to go ahead into the Gpl Interpreter, which will create the TI 9948 environment. We'll press F5 here to go into GPL mode. I am using the menu system here, and I'm going to go ahead and select option P. This is actually going to load the program image, actually not from the Tippy, but from, in this particular case, from my hard drive, because it contains the most latest development image I've got. And it pulls it off, in this case, the MyArc HFDC. But loads the program up, got the program name, it's doing all the necessary setup for the Tippy, and right now it's just waiting for a call. The system gives you a little bit of a status there as far as what's going on the screen. You see various colors so you don't get screen burned in. And I'm going to go ahead and simulate a login from the sysop keyboard. The bulletin board program is set up so that the user calling in has an option to select 40 column, 64 column, or 80 column. If you're fortuitous enough to have 80 column capability, where you're either calling in with an F18A or a Geneve 9640 that's running a telnet client, you can go with 80 columns. If you're calling in with a Tippy, then you have, depending upon your monitor and your video, you have the option of either selecting 40 columns or 64. I've got 80 column here. I'm going to select 40 columns so everything shows properly here on the sysop screen. Here, a little title screen pops up. You either indicate you're a new user or existing user. I'll go ahead and sign in myself. I'm going to cover up my password here. And away we go. I had this program running on my TI 994A set up with just a Tippy. It was a TI 994A with a Tippy and a 32K expansion with a 8K supercard, and it was running fine. However, it is no longer available to be called in, and the reason is you can thank AT&T to that. I upgraded from AT&T DSL to AT&T wireless internet, and lo and behold, when I went to AT&T wireless internet to get the better rates, I signed up for the 1-year agreement. What they took away from DSL and most other providers is port forwarding. You do need to set up port forwarding, so if you're calling into a router, especially if you've got multiple internet connections, so that the router knows where to send that call to. It needs to go to your particular Raspberry Pi that's connected to the Tippy. They took that away, so I can no longer direct those capabilities from the router. Different individuals have indicated that there's maybe ways to tunnel in through that. I have just not made that effort. So unfortunately, it took off 2 of my bulletin boards from being able to be internet accessible. They're intranet, but not internet accessible. Here right now we see the main menu as far as a user. If you're looking here at this spot right here, that would be in a code right there that would clear the screen and put this menu at the top of the screen. On the screen interpreter here for the syshop in, it just scrolls, everything is scrolled. As you see there, got message bases. You can put in other BBSs. You got a data library, file transfers, news. You can page the syshop, last callers. If you want to leave the syshop a message, you can change the width on the fly. So if you select an option there for 80 column and you prefer 64, or if you prefer 40, it'll reconfigure all the menus and the message editors and so forth for that. What we just saw right now was there's a 3-minute timeout, so if there's no input in 3 minutes, just as you would expect on a regular RS-232 based phone call, so it would actually hang up the connection and wait for the next caller. So what I will do is log in again. It's like 40 columns. And temporarily here, cover up my password. And away we go again. Alright, let's take a quick look here. Message bases. We'll go into that area. There it is. The TI-99.4a, Geneva 9640, programming, buy and sell, other bulletin boards, syshop message. So let's take a look at where most of my testing has been on the TI-99.4a area. We see that there, let's read the messages. See that there's message 1 and message 13. We'll start with message 13. Let's start with message 12. It's likely to be a test that I may have written. Do we want to continue to scroll the messages in case you're logging them? I'll say no. First message, hello, this is a test 80 column editor usage. I hope this enters well without any issue or such. It did. Next message, this is a test for the 64 column text editor. I hope this works without issue for the BBS. Now we're seeing it in 40 column here, and it was written in for 80 column. So it is going to split the words up on lines there. So hit next. So it recognizes that we're in. There's probably a limit on the messages here that could be maintained here. I'm guessing it's going to be somewhere in the neighborhood of 32,000 messages. It is in a single file, and they are being stored on the Tippy. So as long as you're making periodic updates or periodic backups, and preferably what I would suggest is backing up from the Raspberry Pi to a Windows PC, you should be able to maintain a very complete board. I would not think many users are going to ever see 32,000 messages. I'm just trying to be realistic, because I think some of the best boards out there right now may have just a few thousand. We can go to another message base, main menu. If I hit just the enter key, I go back to I just keep on backing up menu choices there. So let's, if I hit key there again, let's see what we have for data libraries. Data libraries, we've got things broken down to news and information, TI-994A, and E9640. Let's select the B for the TI-994A. We got categories for applications, games, programming, utilities, system, or we can search for a file. Let's say we're going to look for something TI Writer. Let's search, and we'll enter a search string for writer. It is not case sensitive on the search, so you can either enter it in all upper or all lowercase. I do need to give Lee Stewart credit here for composing a routine that was case insensitive, and that works quite well. Basically, I've got a text file out there that contains the entirety of all the files, in this case over 3,100 files that's presently on the system, and it goes through and reads that file, and when it finds it, it displays some information. Let's take a look and see what we've got here. You got a progression bar that proceeds here. It's looking for the word writer. So each one of those dots represents a file, a string that it has searched. And there's one right there, BA writer. Tells you the file size, 117,632 bytes. TI writer from XB, Horizon, etc. That gives you the file name, BAWRTR-3Y0. So if that's the file you're looking for, go ahead and write that file name down. You can download it shortly. Then it asks you if you want to continue, yes, no, or continuous. Now if you select continuous, now it's going to go through the remainder of those files. So depending upon if you found the right program or not, or if you just want to look and see all that's out there, we can sit there and wait. I'm going to go ahead and say no, because I'm going to pretend that's the file I'm looking for. And to give you an idea, each one of those dots up there for that progression bar represents a file that it's searched. So 40 columns, and we got 1, 2, 3, 4, 5, 6, 7, 8, 9, about 9 or 10 lines. So it's already checked 400 files there in that brief period of time. So we can drop to the file transfer menu, where you can upload, download, or exit to the main menu. I'm not going to download because I'm on a sysop screen. There is a menu right here, disable IAC checking if enabled. The TCP protocol for Telnet, depending upon the bulletin board you're connecting to and the terminal emulator that you're using, you may or may not need to disable the IAC. If you're connecting to say a Windows written Telnet bulletin board to do a file transfer, typically you would want to disable, or you'd want to enable the IAC checking. You disable it for TI systems because TI systems don't have that protocol fully implemented. But what happens is the Windows Telnet bulletin boards send an extra byte if it sees a certain byte in the data stream that it's sending. The TI interprets that as information that should be included with the file. So we need to drop that one extra character there so we get a proper download. And it's a little bit complicated, but as long as you know, if you're calling a TI bulletin board, disable it. If you're calling a Windows-based bulletin board, enable it. We'll go ahead, hit enter, go back to the main menu. We'll take a look at news. Now, granted, this was looking at, this pulls up different newsletters. This is actually not a good display right here at the moment. And it's actually not what I expected, so I think it looked at the wrong file, or at least need to update a file name. I'm going to hit press Control C to abort. Okay, I finally got it to abort. I'm going to have to take a look at that. It's been a while since I've looked at the news. I have to see what's going on. It's got like last callers, which right now it's just me. I've called twice, but it hung up the first time. Pull the menu back up again. You can vote. Are you a TI or Geneve user? Yes, so you can vote. I've been the only one voting on this particular setup on this computer, so I'll say yes. Main menu choice, let's drop down back again. We got a help screen. Been a while since I've taken a look at that, so let's take a quick look at help screen. Press any key to continue. I've got the press any key in here because with the Tippy, if you don't, things are so fast that depending upon your client that is on the other end, especially if you're on a like a Wi-Fi modem, it can very easily overwhelm the speed there, and you might start losing information. So we got complete help system there, and then it tells you at the end of the file. So let's look at the main menu again. You can page the sysop, do a little bit of that. So if the sysop's around, he's going to listen. It changes the color there, so if the sysop does step back in the room, he can tell that, hey, he's been paged there recently, so you can jump into the call. Let's see what else we got there. Let's go back to the data library. Let's select the B option for the TI-9948. Let's say if we're just wanting to look to see what's out there. Let's look at applications. We drop down into more submenus, databases, multi-plan. Let's look at multi-plan because it won't have too many files there. See what we got. So there we start looking at the different files that's tied to multi-plan. Everything's sorted in alphabetical order. Alright, let's go back to the exit to main menu. So that's pretty much the software. Now, like I said before, for a TI-9948, you can run it with the TI-9948 with the editor assembler 8K Super card. You do need the 32K RAM, so if you got the sidecar 32K RAM with the sidecar Tippy, then you're set up where you can implement a system right off the bat. There is a few configurations that you do need to make, or I suggest. One, you got to, like I said before, you got to specify the port forwarding on what port you want it to send it to, so that your Pi will answer. The source code is there in its entirety. If you want to modify it on your own, it does require the Geneve 9640. But you can do that with a MAME setup emulating that, which is a good example here where Wolfgang Hess out of Germany, he took the program and I set it up for him so that with some macros there, he can configure, or he has changed the text from English over to German, so he can compile and assemble a German version of this very same program, same code. Same thing can be done for other languages should somebody desire to proceed that route. The program also allows you to, so you can customize a couple of your bulletin board names inside the program there, so if you want to change it instead of sector editing, it's very simple to do. There are notes there on how to do it. The macros, or I shouldn't say macros, I should say batch files for running the assembly process from within MDOS is all there. So you just type, you can just do a quick edit on one of the batch files there that automates the process, and you can have your whole system designed and tailored to your needs. And if you need help, there is no problem with me helping you out. Greg Mcgill is also running a copy of the After Hours Bulletin Board software on a TI-99-4A, I believe with a sidecar 32K and Tippy. So I've got options there for him as well that compiles an image for him. Roughly, when I was running it, and I believe what Greg was doing, has selected ports 9918 to be part like the 9918 VDP chip we have in our computer. Wolfgang Hess has set port 61643. Again, that's port 61643, and his web domain name is mytbox99, mytbox99.ddns.net, and it connects to port 61643. I'm going to log off or exit the program here. I'm going to reboot my Geneve here real quick, and I'm going to pull up a copy of my term that's actually uses the Tippy for my system. Tick tock, tick tock. All right, go ahead and pull it up. But I'm gonna phone Wolfgang Hess's computer. Go to the phone directory. Option I there is his domain name, mytbox.ddns.net, and it's port 61643. So click on it. There we go. This is his compiled German version. I selected option 3 there for the 80 column, so I'm going to show it here in 80 column. Pull his program up now. And there's his welcome information, TBox99, bulletin board systems. Go ahead and press enter. Now see there it's displayed in 80 column. I'm going to change the width so you can see what it looks like in 64. There's 64 column width. Now, granted, I've got an extra 16 columns that's not being used over here, so I'm going to change it back to 80 column because I just like 80 column. Let's see, as far as colors he's had, not a lot of people seem to be calling bulletin boards. I would encourage people to call the bulletin boards. Wolfgang's got a very nice setup on his. He's adding files. He's trying to maintain the files that are going on the Atari Age on his system as well, so you can be able to download them straight to your computer from there. Take a look at I'm going to write a message here. I'm going to go into TI area. Let's read, see if there's anything new real quick. There's 111 messages. Let's look at message 111, just see what he has to say. That right there asks if you want instructions. That's the German version of it. So no, I don't need it. I know what I'm doing. It's actually from me to Wolfgang. Nice hobby, or excuse me, that was the other way around. To me from Wolfgang. Before date, paragliding. And there's a message. I mean, anybody can go on and read it. So let's back up. Let's leave a message to Wolfgang. let's drop that message there. Let's throw out the message. We don't want to save it. Yeah, I'm sure. I'm trying to remember the order of the translation. My German's been. I think it's asking me who I want to leave it to. Let's go ahead and abort it again. I'm hitting the ampersand. We'll throw that message out again. My apologies there. It's been a few weeks since I last have left a message on a bulletin board. Let's throw out. Are sure? Yes. Let's leave a message. I'm going to leave video demonstration. No, I don't need instructions. Say hey. Just leaving a message as a board for a video for the Chicago Fair. Okay, let's preview that. Got Faire, the word is doubled up twice. I don't think it's actually going to show up. It's asking me if I want to see it with line numbers. No. Okay. Oh, we got a little spelling error in that first line, so let's edit it. That's line 1. Shows me what it was. Let's just say hey. Edit it. Let's go ahead and save it then. Go back to the main menu. Hit the question mark there to give me the screen information again. And we can do a file transfer. But I don't have a file name. So let's take a quick look here on what he's got available for his board. Let's search. Let's do a search string for a test. Okay, I'm going to write that file name down, which is going to be fst16-arc. Something for fast term. I don't want to look for anything more. Now, I do have to turn off the IAC checking. I'm in graphics mode now. Let's look back out of graphics. Okay, I had to find my menu there. F1's the menu for this my term. IAC mode off is at F5. So if you look watching the bottom of the screen, IAC go off. So let's do the file transfer menu. I'm going to download, and I'm going to specify FST16-ARK. Press space, tell me to press any key to. And the file begins downloading. The file transfer can be speeded up on the Tippy side. However, you do have to keep in mind that not everybody has got a Tippy. It's on the other end of the system. and they may be rate limited depending upon their Wi-Fi modem or tippy that they may be using to connect. So I have maintained the normal 128 byte blocks for the file transfer, and it does all the CRC checking for that. So we're proceeding along there at a reasonable pace. Let that finish up here. Now, my term for the tippy here that you're seeing right now, Michael Riccio provided the source code to me back in the early 90s for this program. I did a few tweaks on it, but then I have went in, thankfully, to Tim Tesh and provided ANSI capability to the terminal emulator here. So now it fully supports any ANSI graphics that get sent to it, and because one is using the tippy, you can actually go into full graphics mode and not worry about losing any bytes in the data transfer. That is one of the best advantages here at the tippy, is basically you can request information from the sending system at your pace and display it at whatever pace the computer you're using can process it. So if you're on a TI-99/4A, this is why the TI-99/4A can show, at least with the F18, ANSI graphics and do a very nice job at it, even with a very slow computer, and not lose anything, because you only request the data when it's sent, or it needs to be sent. Oh, this is, I wish it was a little bit faster here, but it is a limitation here. And it's being more driven by not the TI side of the things. Some of it is by the TI side of the things, but it's also by the system here on my end as well. But for a user that has a minimal system like a TI-99/4A, 32K and a tippy, I did release an update to mass transfer that does use the tippy. Again, that included all the source code for it as well, so that users could make any changes to it that they wanted to. And it also has the capability of with the IAC on-off, so you can call other bulletin boards that may be non-TI that would be using that IAC protocol within the Telnet protocol, and be able to transfer the files. Now, if you have the capability for FTP, which Matt has made available with some of his software releases, you can actually FTP programs quite a bit faster. The other option, if you have an FTP site such as Western Horizon Technologies website, you could actually even go into the local host on the tippy itself. If you got an FTP client there, use the FTP client there and grab the file, actually even faster than Matt's. Matt's is the second fastest. The direct FTP client on the Pi is even faster. So it looks like we've got about 8K left here. Now, I don't know if anybody has any questions. If you do have questions on the After Hours Bulletin Board software, you trying to find the distribution, feel free to contact me. My email is beery@uswingnuts.com. Again, that's BEERY@uswingnuts.com. I'll be more than happy to help anybody get something set up if they want to proceed down that line. It shouldn't be that much of an effort, and if you need help, want to change the program name, we can do that. So, program's downloaded, we got it on our computer, and we'll wrap that up here for this session. Thanks, and I hope you have a great day.
Well, for what it's worth, that is the 38th annual Chicago TI International World Fair. This has certainly been a different year, and hopefully next year will be a lot better. Before we go, I'd like to thank all of those people who have made this possible. First of all, Jim Mazurek has done the lion's share of the work. I'd also like to thank my son John, who has been putting all of these videos up on YouTube. Vic Stirrup, our president, has also been extremely helpful. And there have been so many other people who have done all this. I'd like to thank our presenters, of course. Barry Miller, Rich Gilbertson, Eric Firestone, and Greg Mcgill. Without them, of course, there would be absolutely no show whatsoever. So, unfortunately, we don't have infamous pub crawl this year. But on the other hand, you don't have to rush down and feed your meters in the basement of the library, nor do you have to worry about getting your car out before the gates come down at 6 p.m., as we have in the years past. You also don't have to worry about walking around in the ice cold or rainy evening drinking beer and freezing our you-know-what's off. But hopefully all of this will be a one-time shot, and next year we'll be able to get back, meet each other in person, share our experiences, share our knowledge, and share all the new products and new programs that people have written in the meantime. So until then, I will say bye for now from the Chicago TI International World Fair. I'm Hal Shanafield, and it's been my pleasure, if that's the word, to have been your host for this shorter fair presentation. Until next year then, bye for now.